Hi, my name is Guang, 12 years old. For this lesson, we'll be continuing on with another lesson for methods of limit calculations. For this lesson of methods of limit calculation, we have another example. So for this example, just like every other example we have done thus far, for this kind of questions, and we'll be using three methods. So our example for this lesson, we are given limit x approaches to 2, x squared plus ax plus b over x squared plus x minus 6, and we are supposed to find the values of a and b by using this information. So what we have over here, as I told you, we are using three different methods, and you can tell immediately from the denominator that if you substitute it in, it will be a 6 minus 6, so here you have a 0 as a denominator. So for this part, for our first method, what we have over here is the L'Hopital's rule. So for the L'Hopital's rule, what we'll have is that, so on our first step, I'm just going to write down the question again. So over here, you can tell from the denominator is 0. So over here, for this part, what we'll have over here is the indeterminable form. After all, we are using L'Hopital's rule, 0 over 0. And so over here for this part, what we'll use is obviously the L'Hopital's rule as stated above. So on our denominator, we will have 2x, and then we'll have 2 plus 1, and then you have a 0 at the back because this thing once you differentiate it, it becomes 0, while over here on the numerator you have 2x plus a instead. And now if you substitute the x inside, you realize that it's not indeterminable form anymore, and thus you'll get 4 plus a over 5, which is equals to 2, and thus 4 plus a is equals to 10, and thus a is equals to 6, and that's what we get for a. Now for b, because we tell this is 0 over 0, so we're going to let limit x approaches to 2, x squared plus ax plus b equals to 0, and thus over here, if you substitute this part inside, what you're going to get is 2 squared, which is 4 plus has 2a, so you already know what a is, so you can stub it in already. So 2 times a, 12, then plus b needs to be equal to, so this will be equal to 16 plus b, which is equals to 0, and thus b is equals to negative 16. And that is our answer for our first method. Now moving on to our second method, we will be using factorization. So method 2, factorization. So over here for our first step, once again copy the question, give me a sec. So over here what we are going to do is we are going to factorize both the denominator and the numerator. So apparently for her denominator, it will be easier to factorize because you straight up have x minus 2 times x plus 3. On the other hand, for the numerator over here, what we have will be, so we are going to have over here a x plus, so both of them are definitely plus. So here we will have a x plus 3 because this is the only plus over here. And then after that, the other one, because we cannot tell just yet because over here A and B, we are going to have, oh never mind. Over here we are going to have our x minus 2, and then after that, head here we'll have x plus c. We do not know what c is because you literally cannot tell. And from this part, you can simplify the x minus 2 and you'll be left with x plus c and x plus 3. Whereas if you substitute inside, it would not be an indeterminable form. So here you'll be left with 2 plus c over 5, and this will be equals to 2. So over here you times, you get 10, so 2 plus c is equals to 10, thus c is equals to 8. But over here for this part, so what is a and b even if we know what c is? So over here for this part, x squared plus ax plus b is supposedly equals to x minus 2 times x plus c, where what you get for this part will be, so if you times these, you'll get x squared minus 2x, then after that you plus cx, then after that, once again, you minus 2c. So over here, if you put these two together, what you get is this. And thus, you can tell from only the coefficients are equal. So for this part, what you have is that a is equals to c minus 2, which is 8 minus 2, which is 6, and then b is equals to negative 2c. So b is equals to negative 2c, which will result in a negative 2 times 8 was a negative 16. So over here, this is for our second method, factorization. Moving on to method 3, what we'll have here will be we'll still have factorization. It is just that other than factorization, we also have another method which is called partial fractions. So over here we have both factorization and partial fractions. So for our first step over here, we will still we'll just straight up copy the question. So what we'll have here, limit x approaches to 2x squared. So now that you have gotten this part, for the factorization part, we will only factorize the denominator. And then when we factorize the denominator, what we're going to get will be this. So the denominator will be x minus 2 times x plus 3. And then for this part, what we're going to have now for the limit over here, we're going to have two partial fractions. So here 1 plus, because over here the quadratic formula for this part what we'll have is the coefficient of this x squared part is 1, so here we have 1 plus, then after that for the next part we also have our x plus 3 and our x minus 2 equals to 2 over here for this part. And over here you can tell that d is equals to 0 because that the denominator approaches to infinity because 1 over 0, and since this is approaches to 0 while this is absolute 0, this whole thing just becomes a 0 rather than an indeterminable form. On the other hand, over here we have 1 plus c over x plus 5, whereas x plus 5 over here, it will substitute put inside, it wouldn't be an indeterminable form, so you can just straight up do it. And thus c will be equals to 5. And now that you know what both d and c is, what you're going to have now is that you're going to equate these two steps together. And if you're wondering in what way, over here what we're going to have is x plus 3. This part is straight up 0, so we can ignore it. So x plus 3 times x minus 2. Then after that, the next part what you have will be plus 5x minus 2, which is equal to this part, x squared plus ax plus b. So what you're going to have for this part is going to be x squared plus x minus 6, then plus 5x minus 10, which is equals to x squared plus 6x minus 16, whereas over here 6x minus 16 is equals to ax plus b. So you can tell from this part, ax plus b, a will be equals to 6 and then b will be equals to negative 16. And here if you compare the three results that we have gotten, they're the same. So you can tell that over here it is correct. So the first method we basically use the L'Hopital's rule, whereas over here it's 0 over 0. And then after that we found out b by using the 0 over 0 part for the numerator. Well, for the second method you simply factorization both numerator and denominator. For numerator you have to make an extra variable c here, and after you find c, then you can find the a and b which are supposed to find. On the other hand, we have the last method 3, factorization and partial fractions. Well, for the factorization part, it's same as the method 2, it's just that only for denominator. While for the partial fraction, after the denominator factorization, what we mainly did was that we separated over here where the 1, and basically we have the 1 for the coefficient for x squared, and then for this part it will be equal to 2 because that's what we're given. And then d, because the denominator approaches to 0, so the numerator, if it's equal to 0, this whole part just becomes 0. While for this part, because it's not indeterminable, it's a determinable form, so you can straight up solve it. And once you do that, you can basically just relate these two steps together and solve what a and b are. And just take a quick look. And now, last but not least, thank you for your watching.